feel like I have more of these than I should. Any people still need a copy? All right. Was that a handout? Okay, you've got a copy. Okay. So, what did we do last time? We talked at some length about how do you measure angles. What does it mean to associate a number to an angle to say how big it is? We alluded a little bit to these trig functions, but starting today, we'll really commit ourselves to their study in earnest. And so, I think it's appropriate to start by just writing down the definition of the things. So remember, a function is any rule that's well-defined that starts with some input and gives you an output. And it should be well-defined. If I give two different people the same inputs and the same instructions, they should be able to give me the same output values. So let's write down some set of instructions and see how they look. So here's some instructions. Step 1, start at the point 1, 0 on the unit circle line. So there's the unit circle. That is the circle of radius 1 centered at 0, 0. So there's the center, 0, 0. We're going to start at the point 1, 0. Now, rotate counterclockwise. By some angle of theta radians. You will now land at some point on the unit circle. It'll have an x-coordinate, and it'll have a y-coordinate. All right, so far does all of that seem like well-defined instructions? If you tell two people to start at the same point and rotate by the same angle, they'll both wind up at the same x, y coordinate. The trig functions are now just determined by those x and y coordinates. The cosine just records that x value. The sine of theta records the y value. The secant of theta records the reciprocal of the x value. So 1 over the x value. Well, so I guess there's a domain issue. If I need to divide by x, then what can x not be equal to? 0. I can't divide by 0. If the x is 0, then that's bad. Cosecant is 1 over the y coordinate. So I guess that means y better not be 0. If y is equal to 0, then that angle is just not in the domain. Tangent is the y value divided by the x value. So I guess x better not be 0. Cotangent is the x value divided by the y value. So I guess y better not be 0. How do those definitions feel? Maybe a little bit contrived and unintuitive why you would want to care about the things for secant, tangent, cosecant, and cotangent. They all do have very geometric origins. They give you some distances between points in a diagram. I'll focus mainly on these formulaic things. Maybe I'll point out one thing. Tangent is definitely something quite geometric right now. In that let's just read off some instructions. So you rotate by some angle theta, you land at some point x, y. There's the point 0, 0. Focusing on this line. Well, that's a straight line statement, right? So you can talk about its slope. The formula for slope we have requires you to know 2 points on that line. Do you know 2 points on that line? Yeah, 0, 0, and xy. Is that enough information to compute its slope? In fact, what do you get if you compute the slope? Gesundheit. What do you get? Y over x. Oh, cool, that's tangent. So here's one bit of geometry. Tangent theta. This translates from an angle to a slope. So that means that if someone tells you that they want you to build a ramp with some fixed angle, you can figure out the slope of that line by computing its tangent. Nice. So the first thing that I think is reasonable to do now is we have some instructions that define some functions. If these functions actually make sense, then at least for some carefully contrived inputs, we should be able to just understand outputs. Like, it's kind of hard to understand what 2 to the square root of 2 should mean, but you can just know that 2 to the 3 is 2 times 2 times 2, which is 8. Let's play the same sort of game with trig functions as follows. So we'll call that an angle of pi over 2 radians is a right angle. 2 pi is all the way around the circle, so pi over 2 is a quarter of the way. Yeah, that's a right angle. So let's try to compute trig functions at pi over 2, and let's do it by following the instructions above. So the instructions say, start at 1, 0, rotate by this angle theta, which in this case is a right angle, see where you land. If you start at 1, 0 and rotate forward by a right angle, where are you? Zero at 1, right? If you start at the x-axis and rotate counterclockwise at a right angle, you get to the y-axis. Ooh, so that means x is 0, y is 1. All of the trig functions are given in terms of those x's and y's. Is that enough information that you can now just, well, that is definitely enough information that you can compute the rest of the things in this coming set of blanks. I'll see how people feel. Would people rather I talk through or just be quiet for a minute? People want me to keep talking through this set of 6 blanks? Nice, let's do it. So, cosine is the x value. And what did we just get the x value to be? 0. Cosine of pi over 2 is 0. Sine is the y value. What did we just get the y value to be? 1. So the sine of pi over 2 is 1. The rest of these steps, I guess, require you to evaluate a fraction, but I think that'll be okay. So tangent is y divided by x. Nice, so let's plug in and see what happens. What's the y value? 1. X value is 0, so this should be 1 over 0. What can you tell me about that? Doesn't exist. So it looks like pi over 2 isn't in the domain of tangent. It gives you an output that is nonsense. Secant of pi over 2. Let's play the same game. Secant is 1 over x. So this will be 1 over, the x value is 0. What can you tell me about that? Undefined. Cosecant is 1 over y. So 1 is just 1. What's the y value? So this will be 1 over 1, also known as 1. How about cotangent? Ooh, maybe I'll give this as a multiple choice. Zero 1, negative 1, all undefined. So cotangent of pi over 2. A? B? C? D? Cool. Looks like there was some controversy. Let's try to walk it out. So cotangent is x over y. All right, what's the x value? 0. What's the y value? So this is 0 divided by 1. What is 0 divided by 1? 0. Right, 0 can be in the numerator. You can divide 0 by a number. That results in 0. You can't have a 0 in the denominator. Nice. Cool. So, here's the thing we're going to fill in as we progress today. And tomorrow. A unit circle with some pre-rendered angles in it. These happen to be angles where using geometric techniques. This is page 121. So maybe I should grab the one from our copy of the notes and not the previous sections. I'm going to take mine and actually physically tear it out because we're going to make reference to it. And I don't want to have to keep flipping through the notes. You can do what you want with it. Let's go through and try to fill in some of these. So that angle of pi over 2 corresponds to this point 0, 1, tangent was undefined. So in this diagram, I'm going to record sine, cosine, sine, and tangent. Let's try to figure out what happens at an angle of pi radians. So, set of instructions. Rotate by an angle of pi radians. So if 2 pi is a full revolution, then pi is half of a revolution. So you rotate half of a full revolution, starting at 1, 0. Figure out what x, y value you land on. Use that to compute the resulting quick functions. Think you can do that? And I would rather be quiet through this, but if people want me to do things to get you started, I'm happy to do so. Anyone want me to start doing it all? Excellent. Then I'll be quiet for a bit. If you have any questions you want to ask me, go ahead and raise your hand. I'll come around. If you even just want me to check your answers, I'm happy to come around too. So, let's see what we got. So you make this rotation, what are the xy coordinates you land on? Yeah. Negative 1, 0. So if you start at 1, 0, you rotate halfway around. Yeah, you should be at exactly the opposite point. Negative 1, 0. So all of the trig functions are now computable. Let's do them. Cosine is sine, tangent, secant, cosecant, cotangent. Oh, nice. Anyone want any of those discussed? Groovy. So I'm going to now go and fill that in on this diagram. I saw a bunch of people were filling this in, I guess basically for memory, right? If you were just filling it in on your own. I guess that means if you can fill it in for memory, you don't actually need this as a lookup table because you already knew everything. I'm going to fill it in anyway because there's some value in memorization. Okay, so -1, 0, tangent was 0. And all of these are the form cosine, then sine, then tangent. So let's make a quick double check. So let's see if your calculator agrees with this computation. So go ahead and take out your calculator, whichever calculator you like to use, and tell me, using that calculator, let's pick one of these to use to check. How about cosine? So cosine of pi. What does the machine now give you? I hear a -1. Do I hear any answers of the form about 0.99? Cool. How many people? All right. So this was, in fact, a planted issue that I want to use to illustrate something. There's more than one way to measure an angle, right? Radians or degrees. The calculator doesn't know what you mean. It assumes you mean the same thing you meant last time you used it. Do you know how to take your calculator and go between radian mode and degree mode? Does anyone not? Excellent, then I won't need to discuss that. Maybe I'll have people check this. So if you go into whatever menu you use to select radian mode or degree mode, you should see something for radians, something for degrees. Does anyone see a third option in that list? What do you see? Gradients, which we will at no point use in this class. But I just find it neat that the calculators actually include that. All right. We feeling pretty good? So, what have we filled in so far? We've done all the trig function computations at pi over 2 and pi. I bet we could do trig function computations at any multiple of pi over 2. Just a matter of figuring out how many right angles you need to go by. So here are a few more computations that I think are perfectly reasonable to do. Maybe 0 is the only weird one, because you need to think about what 0 means. So let's think about 0. So you start at an angle of 1, 0. You rotate by nothing, so you stay put. So if you start at the point 1, 0 and you don't do anything, then what point are you at? 1, 0. I know I shouldn't be ending my sentences with prepositions, but. So the cosine is the x-coordinate is 1. If you start at 1, 0 and don't do anything, you're still at 1, 0. Sine, the y-coordinate, is 0. Tangent is the y-coordinate divided by the x-coordinate. Looks like that's 0 over 1. Secant is 1 over the x-coordinate. So that's 1 over 1. Cosecant is 1 over the y-coordinate. That's 1 over 0. Cotangent is x over y is 1 over 0. That feel pretty okay? So there are two more entries, 2 more rows in this table. And instead of having everyone do all the computations, maybe I'll break things up accordingly. Think about an angle of 3 pi over 2. Think about an angle of 2 pi. Figure out what the trig functions are at those inputs by following the instructions. And then you can use a calculator to double check at the end. But I'll encourage you not to use the calculator on this. Oh, shoot. Let's see. Is anyone struggling to even get started on the problem? Like they don't know how to draw the two-element picture. Cool, then I won't draw element picture. So, 3 pi over 2, I guess that's like 3 quarter revolutions. Each pi over 2 is a quarter of a revolution. So one way to think about an angle of 3 pi over 2, I'm not saying this is the way you did it or should have done it, would be start at 1, 0, quarter of the way around the circle, quarter of the way around the circle, one more quarter of the way around the circle. Ask yourself what point that ends you, what the coordinates are of the point where you land. What are the coordinates of the point where you land? X coordinate seems to be 0. It's right on the y-axis, so the x coordinate is 0. The y coordinate seems to be -1. Right, it's on the unit circle, so its only choices are +1 or -1. And it looks like it's negative. Oh, cool, that's enough, right? So what's the cosine of 3 pi over 2? Is the x coordinate, which is 0. Sine is the y coordinate. And let's just go across the list. Tangent. Undefined, or does not exist, whichever you'd rather write. I guess I'm in an undefined kind of mood today. Secant. Undefined, I agree. Because it'll be 1 over the x coordinate. Cosecant. I hear a -1. Cotangent. Nice. All right, 2 pi. So if you start at 1, 0 and go all the way around the circle, what's the x coordinate where you land? 1, same one you started at. Y coordinate.
0.
Slope. Secant.
1.
Cosecant. Cotangent. All right. So, maybe I'll try to now remember some things. So what are some things we notice here? So that means that this angle of 2 pi also corresponds to an angle of 0. So you could also put a 2 pi down there just to remind you that all the way around the circle gives you the same. You, of course, can't do that for all the possibilities because there are infinitely many angles that get you back there. You could just keep spinning around the circle. So you can't go 2 knots, but 2 pi is the same as that. You'll notice down here, the thing that we just did a computation for 3 pi over 2 is labeled as a -pi over 2. Does that get you to the same point as 3 pi over 2? Yeah. The fancy word for that is coterminal. Two angles are coterminal if rotating by those angles gets you to the same point. And we got x value 0, y value -1, tangent value undefined. Nice. So what we'll do in the coming days is we'll fill in the rest of this diagram using some geometry to do so. And one of those bits of geometry will justify the following. So here's something I won't justify today that we will in the future. If you rotate by an angle of pi over 4 radians, so that's like half of a right angle, you get to the point √2 over 2 comma √2 over 2. That's something that we won't justify today, but for now it's a fact. That enough information to compute all the trig functions? I think so. In fact, in walking around the classroom, it looked like a bunch of people already had done. Anyone feel like they'd like me to talk through the blanks instead of just being quiet? Cool. Make the progress you can. If you want me to answer any questions just one-on-one, there's a detail you're feeling stuck on. or even just something you want me to check. I'll come on out. So it looks like for the most part, people are happy with the possible exception of secant and cosecant. How many people would describe themselves as being roughly in that mode? They're happy with the 4 leftmost entries? Okay, I saw some heads nodding, but that's good. So let's just go left to right then and see how it works out. So what's cosine? Ah, no, cosine isn't the square. Cosine is actually the x value. So this says that you land at this point, the square root of 2 over 2. Yeah. So the cosine will be the x value, which will just be root 2 over 2. So this will be a common theme with a lot of questions that I ask you about like evaluating a trig function given like some information on the circle. The information that I'll give you on the circle will just tell you one of the trig functions, usually on the nose. And then you have to figure out the rest. What other trig function is like automatic to figure out based on this picture? Sine. What is sine? The same. Sine is the y value. Oh yeah, that's root 2 over 2. In fact, let's make one observation. So cotangent and tangent, the next entries, they differ by just swapping which one's x and which one's y. Oh, but x and y are the same for this plot. So if I can do the thing in the first row, I can do the same thing in the second row. So let's do tangent. What is tangent for this thing? I see some ones. Yeah, now that's right through y. So it'll be y value divided by x value. So that'll be root 2 over 2. All over root 2 over 2. And like this is exactly why I like to use the slash fraction when the thing's already in the numerator of another fraction. Otherwise, it gets really hard to read. All right, what's that fraction simplified to? 1. How many people got that by like doing the thing where you multiply by the reciprocal of the denominator? Oh, okay. You would have gotten the same if you had done, but it would have been like harder than needed. Why is this 1? Yeah, numerator and denominator are the exact same things. Oh, cool. So without doing any more work, do I just know what cotangent is? All right. Secant and cosecant, that's where people, I think, felt the most struggle. And really, the struggle is just simplifying the thing, right? Because in some sense, you already know what secant is. Secant is 1 over the x-coordinate, but you know the x-coordinate. So this is 1 over root 2 over 2. How many people just stopped there at 1 over root 2 over 2? All right. You're technically not wrong. Like, that is what it's equal to, but it's not simplified. So, like, WebWalk would be fine with it, because WebWalk can't tell usually. Well, there is a way to set up a WebWalk problem to make you simplify fractions, but, like, I don't know how to do that. So let's walk that out and simplify it more. That looks like division by a fraction. How do you divide by a fraction? Flip it, multiply by the reciprocal. So this is the same as 2 over square root of 2. Is that fully simplified? Maybe I'll just ask, how many people have like that answer unstopped? Cool. Again, you're not technically wrong. Gesundheit. I don't like that I see a square root in the denominator. And we've done a few things of like how to simplify fractions by rationalizing the denominator. You want to like multiply and divide by a thing, because you can always multiply and divide by a thing. That doesn't change the fraction. You want to pick the thing that turns the denominator into something nice. And I think the square root of 2 is a good choice, because root 2 times root 2 is root 2 squared. Oh, that's just 2. So let's do that. So I'll multiply by root 2, I'll divide by the square root of 2, and let's see what that becomes. Numerator is now 2 root 2. And what is the denominator? 2. And the denominator is now rational, so are we done? Well, cancel the 2's, right? So, just the square root of 2. Do we need to do the same work again to compute cosecant? No, because it's like literally the same as the line above. Also root 2. Neato, that feel pretty good? So, you can make computations of trig functions on the nose as long as you know like what point you land on. Because that's what the trig functions encode. Oh, let's see. So this tells you things about trig functions at an angle of pi over 4 radians. It also tells you something about an angle in degrees. And to figure out what it tells you, how many degrees is pi over 4 radians? Here are 45. So pi over 4 radians equals 45 degrees. Does anyone want to do the walk to get that? Cool. Maybe I'll like at least just remind you of this. What do you multiply by to get from radians to degrees? Multiply by 180, divide by pi. And if you just like internalize pi over 4 is 45 degrees, that's fine. But like in general, you multiply and divide by 180 over pi. So, if I want to now ask you to compute the cosecant of 45 degrees, what would you tell me? Yeah, so if I asked you for the cosecant of 45 degrees, that's the same as the cosecant of pi over 4. Oh, it's root 2. So this table also tells you trig functions at 45 degrees. And sometimes you do want to walk in degrees instead of radians. Most of the time in this class I'll want to walk in radians, but there will be occasion. All right, so those are all of the like on-the-nose computations we'll be able to make today. But there's one much less on-the-nose computation we'll be able to make today. You can always tell if a trig function will wind up being positive or negative. And in order to see why, let's answer this question. So no calculators allowed right now. Let's determine cosine of 2 pi over 3. Is that going to be positive or will it be negative? And here's how I think I want to think about this. Let's follow the instructions that define trig functions. So I'll draw a unit circle. Oh, that's actually a half decent circle. Those lines are pretty shit though. You start at an angle of 1, 0, and I want to rotate counterclockwise by an angle of 2 pi over 3. And right now, I think I care about what quadrant am I going to land. So to figure that out, let's remember this corresponds to pi over 2. This angle corresponds to pi, 3 pi over 2 back to 2 pi. So 2 pi over 3, is that in between 0 and pi over 2? No, because 2/3 is bigger than 1/2. Is 2 pi over 3 in between pi over 2 and pi? Yeah. Right, because 2/3 is bigger than 1/2 but less than 1. So I don't know where 2 pi over 3 is on the nose, but it's in this range. It's somewhere in here. What quadrant is that? It's in quadrant 2. All right. So I now just want to know if the trig functions will wind up being positive or negative. So cosine of 2 pi over 3 is the x coordinate. In quadrant 2, is the x coordinate positive or negative? Negative. Sine is the y coordinate. I hear a positive? Think you can do the rest of them? Yeah, I'll give you a moment, and then we'll come together. So all I want with these answers is positive or negative. I guess 0 is technically an option, but they're not 0. So let's just go across that. Tangent 2 pi over 3. Positive? Negative? I think I agree. And maybe there's another option. Is there a call for me to discuss anything about that? Cool, people are feeling pretty okay. Cotangent, positive? Negative. I think the negatives have it, but there was some controversy, so let's talk through it. So cotangent is x divided by y. The x value is negative. The y value is positive. So I see a negative number divided by a positive number, which will result in something negative. That feel pretty good? Secant, positive? Secant, negative. Excellent, I think I agree. Any call to discuss? All right. Last one, cosecant. Positive, negative. All right, I think I agree. Neato. People feel pretty good about this idea? Do you think you could do this with basically any starting angle I give you? And if you do that, what will you wind up with? You'll wind up with I guess like a table like this, but maybe it goes on infinitely further depending on how you interpret things. So angles between 0 and pi over 2, those correspond to quadrant 1, where the cosine is positive, the sine is positive, the tangent is positive. Between an angle of pi over 2 and pi, you're into quadrant 2, where the cosine is negative, sine is positive, tangent is negative. From pi to 3 pi over 2, you get to quadrant 3. Cosine and sine are negative, tangent is positive. From 3 pi over 2 to 2 pi, that's quadrant 4. Cosine, the x value is positive. Sine, the y value is negative. Tangent, remember tangent's like a slope, so the slope of that line is negative. And let's just see, between 2 pi and 5 pi over 2, what quadrant does that put you in? Anyone want to say quadrant 5? No, but that would be like an aesthetically consistent answer, right? But there is no quadrant 5. There are only 4 quadrants. So that's back to quadrant 1 plus, plus, plus. And let's use that to do like one of these entries below. Let's think about cosine of 4. And let's do it by thinking about this logic. So 4 is not a number that we will have the techniques to compute trig functions at exactly in this class. And in fact, there's no good geometric way. What the calculator will do is it'll compute a Taylor polynomial. And it'll give you an approximation that's accurate up to a bunch of digits. But let's try to walk it out ourselves just for positive or negative. So let's start with this question. Cosine of 4, does that mean 4 degrees or 4 radians? Radians. When I don't specify, I always mean radians. If I mean degrees, I'll put the little circle for degrees. All right, so cosine of 4. So to answer this question, I guess we have to decide which of these buckets it is in. Is 4 in between 0 and pi over 2? So to figure that out, let's think about how big pi over 2 is. What's pi pretty close to? 3.14. I think 3 is good enough for me. So pi over 2 will be 1.5-ish. A little bit bigger than that. Is 4 in between 0 and 1.5-ish? Nope. Is 4 between 1.5-ish and 3-ish? Is 4 between 3-ish and 4.5-ish? Oh, cool. So 4 radians is in this case. What quadrant is 4 radians in? So 4 is in quadrant 3. So cosine, positive or negative? Negative. That feel pretty good? So, the thing I want to close with today, I don't think I'll have enough time to say everything I want, so we'll start in on it next time, is, in some sense, the most important fact about trigonometry. So if there's one thing that I want you to really remember, it's the Pythagorean identity. The Pythagorean identity tells you an awful lot about trig functions. It's really going to be central to a great many things that we'll wind up doing. Now let's see. So I know that a bunch of people in this class have already seen some trigonometry in the past. Do you remember what the Pythagorean identity says? Sine squared plus cosine squared is always equal to 1. Sine squared plus cosine squared is always equal to 1, no matter what angle you plug in. And I don't like to, as a mathematician, I don't like it when a fact is stated but no justification is given. And so I try to minimize the number of times I do that in this class. I have done a few times that I haven't justified Descartes' law of signs in any way. There's an extra credit in which you justify the rational roots test that no one's done yet. Anyone planning on doing that extra credit? Okay. You don't have to tell me now. You know the deadline. Let's figure out why this is true. And the reason is just more geometry and a little bit of analytic geometry. So this is a unit circle that trig functions are drawn on. What's the radius of the unit circle? 1. That's why it's called the unit circle. Unit for 1. So that means the length of this line, because that's the radius of the circle, is 1. So the length of the straight line from 0, 0 to cosine theta sine theta is 1. Ooh, do we also have a formula that gives us the distance between 2 points? I mean, we do. How many people just remember it? How many people remember of it? Because we did state it. I get that it was the beginning of the semester. We're going to use it now.
X plus y
Square root. Perfect. Yeah, so it's the difference between the x values, then you square it, and the difference between the y values, and you square it, and then you take the square root. So the distance formula says that 1, the distance, will be equal to cosine of theta minus 0, because there's the difference between the x values, squared, plus difference between the y values, sine of theta, 0, sine theta minus 0 squared. Oh, do the minus zeros actually matter here? Nope. So that means that this is telling me that the square root of cosine squared plus sine squared is 1. That's a more complicated looking formula than needs to be. Ooh, is something hard to read? Okay, let's... No, maybe there's space. Just write it bigger. So, what's the formula for distance? It's compute the difference between the x coordinates. So, in this circle diagram, that was, I'm just going to write it bigger, cosine of theta minus 0. So this distance is cosine theta minus 0, and then you square it. So there's like the delta x squared plus difference between the y values, and then you square it. So that's y minus 0. So sine theta minus 0, and then you square it. And the distance formula also has a square root. So that's what was written there. But then the minus zeros, you look at it and say, oh, I don't care about the minus zeros. So all of this is equal to 1. So you could interpret the Pythagorean identity as saying the square root of cosine squared plus sine squared is 1. But you should simplify formulas as much as possible if you want to use them again. And we'll use this a lot. What can I do to get rid of that square root? Yeah, square both sides? Oh, and maybe here's like a reasonable notational comment to make. It's clear what you mean when you have parentheses around the cosine and then you square it. But mathematicians are lazy sometimes, so they don't want to put those parentheses in. So here's just a notational thing. Cosine upon 2 of theta means cosine theta times cosine theta. So sometimes I'll put the square in that superscript. So here's why the Pythagorean formula is useful. On the previous page, there were a bunch of examples where you had enough information that you knew sine of theta and cosine of theta. Right. I just told you x and y, and then you computed cosine and sine of all of everything. It turns out you can be more efficient with your information than that. There's an equation that relates sine and cosine. If I tell you sine of theta, could you solve that for cosine of theta? Yeah, and I think in the last step there would be you would take a square root to undo a square. So that would introduce a plus or minus sign. So the Pythagorean formula will tell you everything except for whether or not trig functions are positive or negative. Oh, did we just address how to decide if a trig function is positive or negative? Oh, so that means if you know enough to get quadrant information, and you know one fact about a trig function, then you know all of the trig functions on the nose. That's what this next example is going to be. And I definitely can't do it in 45 seconds. So maybe here's what I'll even suggest. If you want to try to make some headway on this example before next time, then starting 5 minutes of class tomorrow will be really pleasant because you'll already know what's going to happen. Nice. And let's see, just for the sake of my own planning, are you going to plan on coming by my office hour today? Okay, you don't need to tell me in advance if you're coming to my office hour. So even if you didn't raise your hand, you are still welcome to change your mind.